Hi guys, let us discuss Ford Fulkerson algorithm for maximum flow problem. The maximum flow problem, it is used to determine the maximum amount of flow that can be sent from a source vertex to a sink vertex in a directed weighted graph subject to capacity constraints on the edges. In the network, we identify the node on the left hand as source node, the node on the right hand as sink node. We want to find the maximum flow from source node to sink node. In this algorithm, we are using two terms. An augmenting path is a simple path in the network from the source to sink that contains the edges with a positive capacity of flow. And another one is bottleneck capacity. It refers to the minimum capacity of all edges along a specific augmenting path, which limits the amount of flow that can be pushed through that path. Let us understand the meaning of these concepts by working on an example. Let us see the example for Ford Fulkerson algorithm for maximum flow problem. In this network, S is identified as source node and T is called as sink node, and the nodes are B, C, D, E. Now the problem is we want to find the maximum flow from S to T. For example, you can understand these edges are like a pipes. Suppose you take S to B, the pipe can carry 16 liters at a time. That is capacity of this pipe is 16 liters. Like that you take B to C, the capacity of this pipe is 12 liters. Like that you take S to D, the capacity of this pipe is 13 liters. Like that you can assume it like a pipes which can carry any liquid. It may be water or oil, anything, but we want to find the what is the maximum flow of liquid from S to T in this network. So let us see how to solve this problem. So first what you have to do, you have to fill it like this. So what I have done, set 0 slash 16. 16 is the total capacity of this edge. So just I have given 0 by 16. What does it means? I have not used anything, the capacity of this pipe as of now. So that is why I have given 0 by 16. That is 16 total capacity. I have not used anything. So 0 by 16. Like that you make it for all other nodes. For example, if you take 0 by 7, that means total capacity of this E to C is 7 liters, you can assume. But I have not used anything. So 0 by 7. So that is what the meaning of this 0 by 7 or 0 by 16 or 0 by 14. For example, if you take D to E, the capacity is 14, but I have not used anything, so 0 by 14. So like that you have to make all the edges are 0 slash the capacity of that particular edge. So next I should identify an augmenting path. So what is an augmenting path? Augmenting path means any path from source to sink. So I have chosen S to B, B to C and C to T. So if you see the capacity of each edge, S to B is 16, B to C is 12, C to T is 20. But because of the limitation of this edge, in the whole path from S to T via SBCT, I can pass only maximum 12 liters at the same time. So that is why I call it as bottleneck capacity 12. That means even though S to B can carry 16 liters and C to T can carry 20, but because of this B to C, I am able to pass only 12 between S to T via BC. So that is why we call it as bottleneck capacity 12. So through the augmenting path SBCT, the 12 flow will take place. That is why total flow is equal to 12. So what is next? Next, I should see that is there any other path from S to T, that is source to sink. Next, we have chosen the path S to D, D to E, E to C, then C to T. So here in this path, what is the value of bottleneck capacity? So for example, if we take C to T, the total capacity is 20. We have already used 12, so remaining is 8. So in this path, we can pass 8. But here we can pass only 7 because total capacity is 7. Here the total capacity is 14. Here the total capacity is 13. But what is the lowest value in this path? 7. So that is why bottleneck capacity 7. So we are using 7 out of 13 here, 7 out of 14 here, 7 out of 7, and here it will become already 12 was used already. So 12 plus 7, 19. So we have used 19 out of 20. So now what is the total flow? 12 plus 7, 19. Next augmenting path, what we are choosing is S to B, B to D, D to E, then E to T. So if you see the capacity, for example, S to B, you refer the previous diagram, we have used only 12, so 4 remaining, but here only 1 is allowed in this path, in this edge, so the capacity is only 1. But here we have used only 7, so 7 out of 14 means 7 will be remaining, but here we have not used completely free according to the previous diagram. But what is the bottleneck in this path? That is S to B, B to D, D to E, then E to T. So what is the least value? 1. That means this edge can carry only 1. So due to that, so I am adding only 1 here. Previously it was 12, but now it is 13. That means I am using 13 out of 16. In this path, 1 out of 1 completely used. But here previously it was 7. But if you add 7 plus 1, 8. I am using 8 out of 14. Previously, this path was not used 0 by 4. But now I am using 1 by 4. So, by this way, S to B, B to D, D to E, E to T, I am able to pass a flow of 1. So, that is bottleneck capacity is 1. So, the total capacity is already 12 plus 7, 19. Now, 19 plus 1, 20. So, now the total capacity is 20 as of now. Next, I should see that is there any other way to reach from S to T. So the another path what we are choosing S to D, D to E, E to T. So now in this path, what is the bottleneck capacity? Suppose here the capacity is 4. Already 1 was used according to the previous diagram. So remaining is 3. In this path S to D, we have already used 7 out of 13, that is 6 will be remaining. In case of D to E, 8 out of 14 was already used, so that means again 6 will be remaining. But here only 3 is available, so that is why bottleneck capacity is 3. So we can send only 3 in this path, S to D, D to E, then E to T. So that is why this value will become 10 out of 13. This value will become 8 plus 3, 11 out of 14. This value will become 1 plus 3, 4 out of 4. That is completely used. So the new total value, total flow is equal to 12 plus 7 plus 1 plus 3, 23. So the maximum flow in this network from source to sink is 23. And also you should verify the diagram by calculating the incoming value to a particular node should be equal to the outgoing value of that particular node. For example, if we take B, so what is the incoming value? 13. So outgoing value 12 plus 1, 13. For example, if we take D, so what is the incoming value? 10. This side 1, so 11. So incoming value is 11. So outgoing value is 11. For example, E, the incoming value is 11. So this side 7, this side 4, it will become 11. So for example, if we take C, what is the incoming value? 12 from this side, 7 from this side, 19. So the outgoing value is 19. So except source and sink, for all other nodes, the incoming value should be equal to the outgoing value. So with this, we can find the maximum flow in a network. So in this graph, the maximum flow is 23.